Hi everyone, my name is Cynthia Hermosillo, and my presentation today will be on a circuit of the brain that research has shown to play a role in depression. This is a topic that falls under many of the broad topics we got to choose from, but I would categorize it mostly under psychological disorders and how the scientific method is used in psychology, or in this case also neuroscience. I picked this topic because depression is a very complicated disorder that affects so many people worldwide, including myself, and it needs more awareness and scientific research. So, like most things in neuroscience, depression is much more complicated than just some genetic mutations. It is thought that depression can be similar to the response to aversive stimuli. So, first, let's quickly recap some information about reward, which we have already talked about in class. Reward responses happen in areas of the brain called the substantia nigra pars compacta and the ventral tegmental area, which are part of the midbrain of the brain. Recall the monkey study that we talked about in class. So when the monkey got a reward without expecting it, there was a spike in its midbrain, dopamine neurons. But there was a decrease in the firing of these neurons when there was an expected reward, but no reward was received. So, what could be causing this decrease in dopamine firing? The answer is the lateral habenula. It is a region of the brain that has projections to the substantia nigra. So, dopamine neurons in this region of the brain react in the opposite way to the dopamine neurons of the substantia nigra and the VTA. They fire more when there is no reward and less when there is a reward. So this suggests that the lateral habenula is involved in negative reward processing. We can see that in the figure to the right, where you can see like there's a dip in habenula neuron firing when there's a reward, but a big spike when there's no reward. And the opposite is true for dopamine neurons, as you can also see right next to it. There's a huge spike in reward in the dopamine neurons, but there's a dip and there's no reward. So what does any of this have to do with depression? Well, the lateral habenula in mammals, and researchers mostly use mice models. So mammals who are depressed is more active than those who are not. This means that the neurons that connect to the substantia nigra and the lateral habenula become more potentiated and will fire spontaneously at a greater rate, as seen in this figure at the bottom. So WT stands for wild type, and that's a normal mouse that isn't depressed, while CLH stands for chronic learned helplessness, which is another way to measure depression in mice. And so that mouse is depressed, and you can see that there's a lot more firing in the depressed mice in these neurons than there is in the wild type. So lastly, I would like to talk about how this circuit can be used to treat depression. So recent research has shown that ketamine can be used as a treatment. Adding ketamine locally to the lateral habenula blocks the NMDA receptor, which, without going into too much detail, is a glutamate receptor, and it is also needed for the firing of these neurons. So researchers use mouse models for these kinds of studies as well. So when mice are depressed, they don't really want to eat or drink anything sweet. So a sucrose preference test is commonly used to measure the level of depression they may have. So this figure shows that the more ketamine the mouse is injected with, the more they have a preference for sucrose as compared to a saline solution. And this research is very recent, it just came out last year, but I can imagine that it can be very controversial. Anytime any recreational drug is proposed to be used as a treatment for any kind of illness, there is some controversy, and this study is also only done in mice, so until this research goes into clinical trials, we can't really say how it will work in humans. So lastly, for my summary and importance, the research in this circuit is very important because understanding the pathways that are involved in depression can help researchers find a better treatment and maybe even a cure. the current antidepressants we have on the market aren't super effective for everyone, so new research and treatments are always welcome. And here is a list of the references I used, and they're all from papers published to the popular science journal Nature, so they have all gone through the extensive peer review process and are considered to be accurate and valid. Thank you.